4. I made you do this last year a little bit. Then I showed you how to use cover and do it. Cauchy's bound takes a polynomial and it reduces the x values you have to look at. Maybe you remember writing out all the list of zeros that you could be. Cauchy's bound takes that and limits it a little bit for you. And of course the notation's horrible here. But you've got an interval here. M is the largest coefficient you can find. A sub n is going to be the first term. All right? And the left bound would be take away 1, the right bound is add 1. And it's not actually a hard theorem. If you look at your polynomial there, 2x to the 4th plus 4x cubed minus x squared minus 6x minus 3, what's the biggest number?
6. Negative 6.
And notice the absolute value bars. Talks about absolute value. So Cauchy's bound would take 6, divide it by the first piece, 2, take 1. That's the left boundary. The right boundary is 6
Hold
over
on,
2.
so the first one's negative.
And the left boundary and the right boundary. Take away 1.
Yeah, but it's negative n over a. So
Oh, thank you. Anyways, crank out the math. Negative 3 minus 1 is negative 4. 6 over 2 plus 1 is 4. If there are any real zeros of that function, they exist between x values of negative 4 and 4. That's it. That's where they're at. Right. So let's jump ahead and talk about rational roots theorem. Rational roots theorem, I think we talked about yesterday, or we talked about it recently in this class, where you find the possible list of zeros. How long ago was that?
like 2 days, 2 or 3.
1 to 2 days ago. But here's one that's worth doing. Use the rational roots theorem to list all the possible rational zeros of f of x. I didn't even record, did I? I got my laptop turned around so that I could record because we have so many out. And I never recorded. Or did I? I did. Anyways, the idea is you take your factors of c and you divide them by factors of a. So c is 3. It's a pretty small list, isn't it? Plus or minus 1, plus or minus 3. And a is 2, plus or minus 1, plus or minus 2. If this thing has a real zero, it's in that list. Sorry, if it has a rational real zero, it's in that list. If you wrote this out, you'd have plus or minus 1, plus or minus 3, and what else?
Plus or minus 1/2. Plus or minus 3/2.
That's right. So you've got 8 choices to make if you do synthetic division. Maybe you guys pick stuff at random, do synthetic division. That's what this section is.
You'd have to do all 8 of them.
No, you just have to find enough to reduce it to a quadratic. Because once you get down to a quadratic, what can you do? Factor or
Quadratic
formula. So find the horizontal intercepts of this thing, 2x to the 4th plus blah, 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 blah.
So find the.
And your legit goal is to guess zeros until reduced to a quadratic. That is your goal. Now, we can go ahead and we can set up a boundary of things to look at. That's not too hard. You can do Cauchy's bound. We already did this one, didn't we?
Yeah.
I think it's from the first example.
It is.
If this thing has any real zeros, they're between negative 4 and 4. All right? Now, if we write out our list, I don't know if this game is anything. Did we just do this? Is this the same one we just did?
Yeah, I'm writing it.
Yeah. Your potential zeros. So his little boundary didn't do us any good on this. That happens a lot. That's why I never taught it. At least an algebra 2. Your potential zeros are plus or minus 1, plus or minus 3, plus or minus a half, and plus or minus 3/2. So this boundary, useless.
Awesome. Love that.
It's not all that useful. It's really not. But it's useless here. Because your choices
Are all between
are all between there. I mean, they're -3 to 3. So now his does say real zeros. That's rational zeros. There's a difference. There might be a real zero that's -3.56 something. Okay? That might happen. Guess, and check, and guess and check, and guess and check, and guess and check. There's your list of zeros. You got 8 choices. Pick one. Do synthetic division. Somebody make a guess. What do you want X to be?
Obviously.
1.
Obviously 1. 1 should always be tried.
I don't know how to do this.
You don't know how to drop, multiply, and add?
I just didn't have to.
1 times 2 is 2. 1 times 2 is 6. 1 times 6 is... I haven't actually formally taught you synthetic division yet, have I, this year?
Not this year.
No, I haven't. I forgot all about that. For some reason, I'm thinking I did. Drop, multiply, and add.
B and A, add the other A, and you're in for a good time.
So true.
Anyways, the idea was drop, and then you multiply, and you add. You multiply, and you add. And then after you do that, you multiply, and you add. Then you multiply, and you add.
And you stand, because you have a remainder and -4.
Which is, this is
So that
it.
is a -1.
No, Micah says try -1.
Oh, yeah, because it's
Why not?
minus. Why?
Well, you've already got a 1 there. Put a -1 there now. See what happens. So you drop the 2 still. You multiply and you add. That'll give you 2. You multiply, you'll have a -2 and -1, which is -3. And if you multiply, you'll have a 3. And if you add down, you'll have a -3. And if you multiply, you'll have a 3. And you have a 0. And now you're happy. You have successfully reduced it down from x to the 4th into x cubed. Now, this is beyond what your course is asking of you. But what you have done is you have factored out x plus 1. You pulled x plus 1 out, and what you're left with is 2x cubed plus 2x squared minus 3x minus 3. I don't know how good you are in math here, but I can actually stop synthetic division right now. But I'm not going to. You can actually factor at this point in time. It's just a special example. You see how you can factor?
Well, is it that one thing of the, it's in my head, man. I don't know if this is.
Where you like
the
split it
thinking
apart,
of.
is that what you're talking about?
Factoring by grouping.
Yeah, factoring by grouping. Yeah, that's what I was thinking.
It does factor by grouping. But you could cover up. But anyways, I don't know that that's relatively apparent. The idea here is, this is a technique that works where you just guess and guess and guess and guess and guess. It's elimination method. Now, I'm going, see, we already pulled out the -1. And I'm thinking here, I'm pretty sure it happens twice. Try it again. Can zeros happen more than one time?
They can,
Yeah, they can. You know that. I don't know if you remember doing this or not, but you can reuse the material you already had if your remainder was a 0. So, drop the 2 again, you multiply and you add. You multiply and you add. You multiply and you add. By God, you were able to do it again.
Yep.
That only happened twice. I noticed it because I was looking at the factor. Right, that's what I noticed. I always take it forever to sit here and guess that thing happens again. I would have tried something else.
2x squared minus 3.
And what remains again is your remainder, preceded by a constant, preceded by an x, preceded by an x squared. So we factored out x plus 1 twice. And what we were left with was 2x squared minus 3. And that's where the last two zeros are. Yes, no? If that's where the last two zeros are, what do you set it equal to? 0, unless you know how to factor it. Does anybody know how to factor it?
What?
Factor that.
The
How good are you?
Is it
X
like,
minus.
is it gonna be like X?
No.
Oh,
Is it root
actually,
three
get
hash?
it. I think I can do it.
Is it root 3 hash? Is that what you're
Root 3 is in
It's something
Really?
that, yeah.
Well, it's not
Really, like-
root 3 halves.
Where you just go like, you know what I'm saying?
No.
The root thingy that you wanted,
2 root 3.
It's root 2x.
right?
Root
Yeah.
2x plus root 3
3.
minus root 3.
Yeah.
No, it's not.
It's x squared.
Okay, let's just do it by
You
hand.
get 2x squared.
2x times, root 2x times 2, root 2x is.
2x squared.
No, root 2x times root 2x.
Yes.
2x squared.
It's just root 2.
X outside. That's what it's out, right?
It's just root 2 and then the x outside of it.
Yes.
What else would it
Dude.
Well, anyways, since that's beyond you, go minus 0. 2x squared minus 3 is 0. What are you gonna add to both sides?
3.
3. Maybe you can connect the dots after you see the answer. I don't know.
Upright 2.
Divide by 2.
Mm-hmm.
We'll take the root of the top and the bottom. Right? That's kind of what I have here. Root 2x is root 3. And x is root 3 over root 2. No?
Would you have to multiply them?
Oh, yeah, you've got it on the top. Multiply top and bottom by root 2.
Woo! Yeah.
You get root 6 over 2. Over each plus or minus. There's your range zeros.
So, -1 and then
So-
plus or minus.
So you just solve for X and then undo it, basically?
What? No, I did it in my head. I didn't do any of that math in my head. I just know that a root 2 times root 2 is 2.
Yeah, but it's, you get it down to X equals root 3 over root 2, so you can just,
Destroy it, make it look pretty? Yes. Because it's not formal. Even with what I wrote up here, Leo, I would still have to multiply top and bottom by root 2. I still have to do that. Because it's just not formal. Anyways, if you can see something like that, awesome. If you can't, it's okay. Nobody ever asked you to do that before, did
Your
they?
answers were -1 and then plus or minus root 6 over 2.
Yes.
And it's just the 1/2 twice.
No, but nobody's ever asked you to factor anything like that, have they? I wouldn't have expected you to know how to factor it. Not the first time. Second time. Not the
Did you
first
say
time.
1/2 first?
Root plus or minus root 6
Over
over
2.
half.
Over 2. He's just saying half. He means over 2. All right, let's see what Gaussian's boundary says about this, or Cauchy's boundary. Let's find our interval. What's the biggest number you see?
10.
10. So we have a -10 over the a value of 4 minus 1. And we have 10 over the a value of 4 plus 1. This will be the boundary of zeros to look at. So -10 over 4 is what, -2.5? Take away 1, -3.5. Probably going to be useless. The other one's going to be the 3.5. Hopefully you notice the numbers repeat. You figure out one of them, you have the other one. That's how it looks. But your answer, your real zeros are going to lie somewhere between -3.5 and 5.5. And we're just going to do the list, which is plus or minus 1, plus or minus 2. And it's sitting over plus or minus 1, plus or minus 2, and plus or minus 4. So it looks to me like you got 12 choices you can make. So I'm getting tired, so I might not be doing that right.
So what happened?
Yeah, some will have more than once. Anyways, I don't wanna write all that out. What do you wanna guess?
One.
Wanna guess one? That's fine.
It's the factors.
You actually only get 4 choices.
Because I can't writing it out in cancellations.
You
That's
have
not
1,
too bad.
2, a half, and a fourth.
So a 1 was suggested. I don't think it's gonna work. It's not looking pretty.
Yeah, it's not very awesome.
So we tried a 1. What do you wanna try next?
Negative.
Why not? You've already drawn a 1. Plus, there's a lot of negative symbols there. I don't know. It's not looking too good. So, it's not gonna be plus or minus 1.
We got farther from the truth.
We should do, obviously, 4. That's not
You
right.
wanna do negative 2?
2, a. Feel like.
I don't think so.
Obviously, a half.
I'm not the sharpest crayon today, but I don't think that's gonna work. Why don't you try a fraction?
We'll try a half then. A half sounds reasonable.
It does sound reasonable. Half 4 is 2, negative 8, negative 4, negative 6. It got close.
You know, I wish I could just erase that so fast like you can.
Instead.
I'll just stop writing all the examples.
Yeah, that's what a lot of people do.
They just wait and see.
Wait till
Go
the
team.
answer comes around and then I write that one.
So half didn't work.
Negative.
Negative half.
Gotta be negative.
Wrong, it's gonna be negative 1/4.
That'll be funny.
It's just guess and check and repeat. That's a negative 2, that's a negative 12, that's a 6, that's a 4. There she is.
Okay, the short radio.
Okay, so it's negative 1/2, got it.
Now, pay attention to your quotient. You know what I mean by quotient?
The answer?
Yeah.
The 4x squared minus 12x plus 4. Well, you reduced it to a quadratic, right? You actually hit your goal. You have reduced down to 4x squared minus 12x plus 4.
X squared.
You have an x squared. And now you just default back to the easy basic stuff. You should pull out a 4 just because it'll make a quadratic formula quicker. Is it gonna factor?
No.
No. It's not gonna factor, so you can send the students home.
Yay!
A means happy.
Negative.
X equals negative b plus or minus square root. B squared minus 4c all over 2a.
So also just minus 4.
Okay, before we continue, are we doing the number 2 example?
What is the number 2 example?
I need writing space.
Use this writing space.
Okay.
I don't plan on doing any multi. Alright, so if we're opposite b, we're a 3. We're gonna square a negative, we don't worry about signs. We talked about last year, a is 1, c is 1. Opposite and pretty over twice a and is 1. Tristan, you know where a, b, and c came from? Yes. Just checking. And then we do some math. We got 3 squared minus 4, which is 5. I'm glad that it's 5, because I can't do anything with it. So I have 3/2 plus or minus root 5 over 2.
That's your pretty little zeros.
There's your last 2 zeros. And that is all I plan on doing with your day. That's it. Hopefully you got the gist of this. Guess some things for a while, pull them out,